Right, so we're going to expand on what we've looked at a little bit further just now. So the thing with the last few examples is it's always started with a factor for you to begin with. By knowing a factor, then you can obviously just go through the synthetic division process and you can find the other factors using the quotient. But with some questions, it doesn't tell you anything at all, and it just asks you to fully factorize the function from the off. And these can obviously be a little bit more difficult. It's the same kind of idea, but the point is you don't have basically a number to the left of your synthetic division to start working through with. So you have to find that first of all. Okay, so this is what the question would look like, fully factorize just the function. So no factors to start with. So you've basically got to find that yourself. So rather than going through a whole synthetic division and just trial and error each time and just waiting until such a point as you get the 0 as the remainder, what you'd want to try and do here is use the function as is and basically put in values of x until such a point as you get 0, okay? So when you substitute the x's, you want 0 at the end of it all. The 2 kind of helps you. If you look at the 2 and you look for factors of 2 first of all, then that should be kind of a basis to start with, okay? So just try things like 1 minus 1 and then 2 minus 2 until such a point as you get there. So this one luckily works out with 1. So by substituting the x's for 1s, we work out that the whole thing equals 0. So that tells us that it is a factor. So since f of 1 equals 0, x minus 1 is a factor of f of x, in which case we can use that as the basis for our synthetic division. Okay, so 1's a good place to start, but try minus 1 and then go on to 2, minus 2, so on and so forth. Okay, it can be a bit convoluted, but hopefully one of the lower numbers should kind of get you there. Okay, and once you've got that stage, then obviously you can use that with your table. Okay, so start again with all the coefficients. So 2, 1, minus 6, 1, and 2. A few more this time, or one more because we've got a quartic this time. It's the same kind of idea, and then now that we know that x minus 1 is a factor, we've got 1 on the left of our table, in which case we can use that as our multiplier. Okay, so start with a 2, take it and times it by 1. Give us 2, add on the 1, that gives us 3, times by 1, still 3, add on a minus 6, minus 3, times by 1, minus 3, add on 1, minus 2, times by 1, minus 2, add on to 0, okay? Which tells us, which we already knew, to be fair, we knew that it's as a factor, but that's just the proof. And I just write that each time just so we get into the habit of doing it. Okay, so since f of 1 equals 0, x minus 1 is a factor. I know I wrote it already, I know it's this line here, but just to get used to get into the habit of writing it after the synthetic division. In which case it leaves us with the quotient of 2x cubed plus 3x squared minus 3x minus 2. So remember, 1 less in terms of the degrees of the first power should be 1 less than 4, so that's x cubed. Right, we need to factorize this too. If it was a quadratic, then we could factorize it by the methods we learned in National 5, but because this is a cubic, we basically have to do it again, and in which case we actually have to find a factor again. Okay, so in the same way, take 2x cubed, 3x squared minus 3x minus 2, and then put numbers in. It doesn't mean because we've already used x minus 1 that x minus 1 can't be another factor. Okay, it would be a whole second factor. It's not the fact that it's already a factor because we've taken that out. This is what we're left with. So it could still be 1 as a factor, and you'll find out that it is. And what that means is we've got to be careful at the end because we've now found 2 factors that are the same. So we have a repeated factor, okay, or equal roots, as we sometimes call it, obviously. Okay, but so now we can go through and we can take the coefficients that we've just taken from the bottom of our previous synthetic division, and we can use that again with 1 to find out our next quotient. Okay, so 2 times by 1 is 2, add the 3 is 5, times by 1 is 5, add the minus 3 is 2, times by 1 is 2, add the minus 2 is 0. Again, just get into the habit of using that. So the quotient this time is 2x squared plus 5x plus 2. And we can factorize this as a trinomial, but just be careful. What I mean here by be careful with the notation is just the fact that we're rewriting what we originally had as our function, quartic function, but we've basically taken out x minus 1 twice as a factor, in which case it's going to look like that. So these are the same thing. So we're just taking out a common factor of x minus 1, but we've done it twice, and now we're left with 2x squared plus 5x plus 2. If you multiplied this through, you would get back to that. That's the point. But we want it in the brackets. We want it in as many brackets as we can get, in which case we can factorize this still a little bit further. So this is a particularly horrible question because obviously this is a more difficult trinomial to factorize. However you choose to do it, you get 2x plus 1 and x plus 2, in which case that is it fully factorized. Okay. Again, read the question once you think you've answered it because it might not just be a case of factorizing it. You'd have to factorize it to do anything, but you might need to go one step further in terms of solving it, in terms of getting it equal to something else, in terms of finding the root. Whatever the question asks for, just make sure you answer it. This is just factorized fully, and that is what we have here. Okay. You could write this as x minus 1 squared, obviously, but just make sure there are two x minus 1s. Okay. Right, so that's the more difficult one that you get. There's just kind of straight factorization, but there are other uses that we can have for polynomials. Okay, we might actually use it to determine unknown coefficients. So in terms of our formula, we've been using the coefficients. We actually kind of do a reverse of what we've been doing to find an unknown coefficient. Okay, so for example, if you had something like this, so again, it tells us a factor. Okay, we've got x cubed plus 2x squared plus kx as our function. What we want to do is determine the value of k. Okay, so we still set it up in the same way. Okay, because if x plus 2 is a factor, then f of minus 2 equals 0. So we know what we're trying to get here. We know at the end of this we should have a minus 2, but what's going to happen because of this k is that we're going to have a k involved. Okay, so let's just work it through nonetheless. Okay, just be careful with your coefficients. You got 1, 2, k, and minus 2. Okay, and we know x plus 2 is a factor, so we can use the minus 2. Okay, so we got 1 times by minus 2 is minus 2, add on a 2 is 0, times by minus 2 is 0, but then we add on a k, in which case we have 0 plus k, which is just k. We times that by minus 2, in which case we have minus 2k, and then we add on minus 2, in which case we have minus 2k plus 2, plus minus 2, sorry. But the point is we know that should equal 0, because we know that minus 2 is a factor, in which case that needs to equal 0. Okay, so what this gives us is an equation. And if we've got an equation, we can solve it. Okay, minus 2k plus minus 2 equals 0. So minus 2k minus 2 equals 0. Minus 2k equals 2. And k equals minus 1. Right, sorry, we cough and fit there, but I'm still alive, don't worry. Okay, so the point is now what we had to do is determine the value of k, and k equals minus 1, so that's fine. The thing is, you might have a kind of a different question where you use that k equals minus 1 and then you factorize this fully. Okay, so we don't necessarily need to do that for this one. The question only asked us to find the value of k, so that's us done. Okay, so in a situation like this, though, you might have to work back through because this is basically asking us for three things. Okay, so we know that x minus 1 and x plus 3 are factors of this. We're going to determine the values of b and d and factorize fully. Okay, so we want to know what b is, we want to know what d is, and we want to factorize it fully, knowing but that x minus 1 and x plus 3 are both factors. Right, so we've got to think about what this tells us. X minus 1 and x plus 3 being factors means that when we kind of go through with 1 and minus 3, then there should be 0 remainder. So the little box at the end of synthetic division is telling us the remainder when we divide it by that factor. So obviously if it is a factor, then there will be no remainder. So the reason I'm pointing that out is because I've seen there's a couple of questions recently in past papers where it didn't say x minus 1 and x plus 3 are factors. It might say when you divide by x minus 1, you get a remainder of 2. All it means is that in the same way with that last one, we made the box equal to 0. All that would happen here is you make the box equal to 2 or whatever the remainder was. Okay. So if x minus 1 is a factor, then f of 1 equals 0. In which case we can start there. And what we're going to do is we're going to build up an equation, but the equation is going to have b and d in it, which in itself poses issues. And if you're smart enough, you'll realize where this is going to go. Okay, but nonetheless, we've got our coefficients 2, b, minus 4, and d. X minus 1 is a factor, so we're dividing through by 1. Okay, so we're taking 2, times it by 1, adding on b. Okay, times it by 1. And then add on minus 4. Okay, so just be careful how you write it. If it's 2 plus b and then add minus 4, we can take away the 4 from the 2, leaving us with b minus 2. Okay, different ways of writing that, but that's the simplest way of writing it. Times it by 1, and we get b minus 2. And if we add on d, then we get b minus 2 plus d. Okay, right, and that, this is all budged up a little bit, sorry, but b minus 2 plus d equals 0 because we know that x minus 1 is a factor. So we know that whatever we get here, this is our remainder. This needs to equal 0. Because we knew it should be a factor. Okay, we can't solve this equation because there are two variables. Right, when we have two variables in an equation, we need another equation to be able to solve it, and then we do simultaneous equations. Okay, and luckily we know there's another factor, in which case we can get another equation in terms of b and d, and we can solve them simultaneously. Okay, right, so same idea again. If x plus 3 is a factor, then f of minus 3 equals 0. So we're using the minus 3 this time in exactly the same way. Okay, so 2 times by minus 3 is minus 6 plus b is minus 6 plus b, or you could write b minus 6. Times by minus 3, just be careful here, everything's times by minus 3, so it becomes 18 minus 3b, and then we add on minus 4, in which case it becomes 14 minus 3b. Times that by minus 3, and it becomes minus 42 plus 9b, and then you add on the d, and you get minus 42 plus 9b plus the d, and that needs to equal 0 because we know it's a factor. Okay, right, this gives us two equations both equal to 0, and as long as we've got two equations in terms of the same letters, then we can solve them simultaneously. Right, remember you've got lots of different options for simultaneous equations. Okay, you could do it graphically, but this one's a bit awkward for that. So you could either substitute one into the other, okay, or you can do it by elimination. Right? I know most of you are used to the idea of elimination, so I think I go with that one. Okay, so just simplify them a little bit. I've added 2 to both sides here to get b plus d equals 2. And then I've added 42 to both sides here to get 9b plus d equal to 42. Because we've got a d in both of these, I can just do one taken away from the other. So I've done the top one taken away from the bottom one. So 9b take away b leaves me with 8b. D take away d leaves me with no d's. And 42 take away 2 gives me 40, in which case b would equal 5. And then I can use that in either of the equations. Obviously, the first one's easier. So 5 plus d equals 2, in which case d must equal minus 3. Okay? So that's only part of the question. Again, when you think you've answered the question, go back and read it. Okay, we had to determine the values of b and d, which we've done, and then we needed to fully factorize. So I need to take these values and I need to fully factorize. So this is just giving us the values, and then we substitute into either quotient before factorizing fully. So this is the beauty of this question now. Now we've got two quotients. Okay, and you can take these b's and d's and you can substitute them in. What a lot of people I think try and do in this case is put it back into the original one and then do the whole factorizing again. It will work, okay, but you've done this the synthetic division already. You might as well just substitute into either of these. Okay, so I think I'm probably going to use the first one because it looks a bit more straightforward. So the 2 plus b and b minus 2. Okay, they're my quotients. So it's 2 times by x squared, 2 plus b times by x, and b minus 2 obviously at the end as of my constant. And if I know b is 5, then I can just take all these b's out and replace them with 5s. 2 plus 5 is 7, 5 minus 2 is 3, so I get 2x squared plus 7x plus 3. To be honest, I know one of the factors. X plus 3 is the other factor, so I know this basically divides by x plus 3. I've just got to work out the other one. X minus 1, x plus 3, and that would leave me with 2x plus 1. So I can use that to help me, the x plus 3. Okay, the fact that I know this must divide by x plus 3 because I know x plus 3 was a factor in the first place. And then I can work out the other one. Okay, it's pretty straightforward from there because obviously if you've got 3 here, and the 3 here, sorry, it's going to be 1 in terms of the other bracket. If I've got x here, it's going to be 2x in the other bracket. So it makes your life a little bit simpler. Okay, so that's it fully factorized. Again, just be careful, it might ask you to solve it, and if it was equal to 0, then you've just got x equal to 1, x equal to minus 3, and x equal to minus a half. Okay.